So now let's talk about in this chapter equilibrium of a rigid body. By the word equilibrium, we must automatically have a mental image that the the net force or the net external force is equal to 0. So equilibrium means there is a balance of force, and therefore if there is a balance of force, there is no net movement. That is, it will if the body was in motion, it will be in motion. If the body was in rest, it will be in rest since it's in equilibrium. So basically equilibrium of forces is actually equal to, say suppose in this particular object, different types of forces have been applied: F1, F2, F3, F4 till Fn. But we say that this body is in equilibrium. That means the net force F1 plus F2 plus F3 plus till Fn, which is equal to summation of Fi, where I starts from 1 to n, is equal to 0. So this is what equilibrium of a rigid body actually means. So there are two kinds of equilibrium. One is translatory equilibrium, another is rotatory equilibrium. In translatory equilibrium, let's discuss about translatory equilibrium. Say suppose this is a plate. This is a plate with a edge, the cone-shaped edge below, and it's rotating. It's rotating with the angular velocity omega about a fixed axis. Say O and O dash. Okay, so when we say that this is in translatory equilibrium, we see that this is rotating about its fixed axis, but there is no motion, or there is no acceleration in this part. That is the translatory motion, that is one particle moving from one place to another, all the particles moving with the same velocity. This does not happen. So we can say that this particle is in translatory equilibrium. Similarly, if a rod is moving but it's not rotating, then we can say that it's translatory. It has a translatory motion, but its rotatory motion is not there. So it's in rotatory equilibrium because no net force is being applied. So this is what we can understand. Now there is another term that you will come across in this particular topic, and that is, so what do we understand by couple or torque? Now the best example to give you is, say suppose you have a bottle. This is the bottle that you have, and you're trying to open this bottle. Let's say what happens. So you put your fingers over here, you put one of the fingers over here, you put one of the fingers over here, and you put another finger over here, you put another finger over here, and you try to open the bottle, So what you are doing is you are applying torque in the opposite direction, but this torque in turn is actually adding up. Say suppose this is your stick, you are applying a torque over here and you are applying a torque over here. So this will undergo a rotational motion. Say suppose in this stick you are applying a force here, this. So this in turn is trying to rotate, It won't be going this way or in this way, but it will try to rotate. Because the forces are not balanced. Since the forces are not balanced, this this part will push you in this way, this part will push you in this way, so it will try to swing or to take a circle. So now you can see is that actually you are helping in the motion of the swinging of or the circling of the rod, and similarly you're helping in the motion of opening the bottle. This type of forces when applied in the opposite end, this is known as your couple or torque. So this is what you can understand while using the term couple or torque. Another best example is your magnetic needle. This is north, this is south, this is east, this is west. So a force over here and a force over here, because the magnetic south attracts the compass north and the magnetic north attracts the compass south, and therefore a force is applied in opposite ends, in opposite directions, and therefore your compass needle moves. So this is the reason why you can use compass.